Okay, so this is hint number one for this problem, and this is a problem I really like. And the reason that you're given this problem is because we have an example of a place where the derivative does not exist, and yet that point is part of the domain of the function, which makes it an interesting function. So the hint that you were given was going to be to take and do the derivative using the power rule like this. But then what you want to do is you want to take that and change it into a fraction. And the reason we write it as a fraction is because when we have a fraction equal to 0, we can simply set, so in other words, when a fraction is equal to 0, set the numerator equal to 0 and then solve. And I'll let you actually go about doing the solving piece of this. So the hint that I wanted to give you was, if the derivative does not exist, we take the denominator, set it equal to 0, and when we solve that, we get x is equal to 0. Now, x equals 0 is part of the domain of the original function, and that's what makes this graph interesting, as I said before. In particular, what we get out of it is we get the derivative value is equal to 1 over 0, or infinity. So we get a tangent line which is going to be vertical. Now, what that's going to mean for the graph is this. So we've got the graph, and it's coming along here. And as it gets closer and closer to x is equal to 0, the tangent line is going to go more and more vertical to let that one point right there, the graph is going to go completely vertical, and then it's going to start going back on track there. So that's what makes this interesting, and I just want you to be sure you understand when we get the derivative not to exist, this is the result that we might get. We might get a vertical tangent line out of it. The hint for the third problem that I have for you is really having to do with how we solve this derivative. So we have f of x equals x times e to the negative x squared over 2. We're going to do the product rule to be able to take the derivative. And the hint for you is this: factor out e to the negative x squared. And that's going to be a common factor. And the reason we factor it out is because we are going to take this and essentially set it equal to 0. Set it equal to 0 and does not exist. And now we have two factors. One of the factors, that's pretty easy. We take one of the factors, set it equal to 0. That's going to be easy to solve, and so you guys can do that. The other one is setting e to the negative x squared equal to 0, and this one is going to have no solution. And what I want you to know about this is the reason it has no solution. There is no value of x that you can plug in to be able to get 0 out of it. And a way to be able to check that is if you were to try to solve it, what you would do is you would natural log both sides. And when you tried the natural log, the right-hand side, the natural log of 0 doesn't exist. And so that's when you would see there was a problem. As far as the solution of e to the negative x squared over 2 times the quantity 1 minus x squared equal to does not exist, there's no division by 0, there's no square roots of negative numbers, there's no natural logs in this function. We might have to use them to try to solve something, but there are no logs in there, so there's going to be no solution to this one as well. So make sure you understand that piece of it. And then the third one, this is really about organization. So the first hint is going to be regarding the x-intercept, finding the x-intercepts. We've got this as the product of two functions, so we set each of the factors equal to 0. And when we were to solve this, what we're going to get is two things which seem like they can't be connected together. So my hint for you is this. Actually write out what these numbers mean. So this right here, this is going to mean pi over 2, 3 pi over 2, 5 pi over 2, and so on. This is going to be 0, this is going to be pi, it's going to be 2 pi, and putting them together gives you these values right here. So the hint for that I have is that it sometimes is easier to be able to view these as individual numbers, as a list of these numbers here. And when you end up writing the value of the, what the points are going to be for the x-intercepts is going to be, you could just write it as 0, 0, because the y value for all these points is 0, comma, pi over 2, comma, 0. And you probably want to go and do 2 or 3 more of those before you do a dot, dot, dot to say that the pattern has been established. So that's a hint for you on how to organize that. And other hint that I have for you is when you take the derivative. When you take the derivative and you simplify, you're going to end up getting this, and this is not easy to solve. But we have an identity which says that is equal to cosine of 2x, which is much easier to solve. The trick is for this is going to be when you take the derivative and set it equal to 0, you're going to get 2x is equal to pi over 2 plus n pi, because that's where cosine is equal to 0. Remember, this means n is any integer. And then what you want to do is you want to divide by 2. So imagine dividing each of these by 2. Pi over 2 divided by 2 is pi over 4. N pi divided by 2 is n pi over 2. And again, it's tough to see what these actually look like, so it's worth it to actually take and write these values out. These are all critical values. And then the next thing you have to do is you have to find the corresponding y values. And here's a suggestion I have for you on that. Make a table. Because this problem, there's a lot of patterns in terms of this table. And so that's what we really want to do is we want to establish a pattern here. So if we plug in negative pi over 4, as you can see, we get negative 1/2. When we plug in pi over 4, we end up getting a positive 1/2. And that pattern is going to stay the same. It's going to be negative 1/2, negative 1/2, and that's a pattern which is going to be established as you go along. Okay, so give those problems a try and bring your questions to class on Thursday.